Now I'm sure this will come as no surprise, but you can use numbers in Python. In fact, there are different numeric data types that a value can be. For example, we could have a number which is an integer, which are whole numbers without decimal figures. And for these types of values, we use the int keyword. So an integer could be used to store the number of steps you make in a day, for example. So I could type daily_steps equals 10,000. And then we could type an end of line comment saying hash this variable is storing an integer. And just to prove that this variable is indeed storing an integer value, we can use the built-in Python function called type to see what object we are working with. So we can write type and then put a set of brackets, also known as parentheses, just like we saw when we called upon the print function earlier in the course. Inside the parentheses, we can put the variable name, so daily_steps in this example, and we can place this inside the type function. When we run this, it brings back a result telling us that this is an int object, i.e. an integer. Now there may come a time when you want to use a number containing decimals. This can be achieved by using what is known as a floating point number, and we use the keyword float to denote this. So if I were to create a variable called film_rating and assign this the value 7.5, we are now storing what is known as a float inside the variable named film_rating. And if we check to see what the type of object stored inside the variable is, we get back the type float, just as expected. Now within the formal Python documentation, there is a section which references issues and limitations of using floating point numbers in arithmetic, and I've attached the relevant documentation in the resources section for you to take a look at in your own time if you're feeling inquisitive, but we won't go into any detail on this topic as of now. Now hopefully it is unsurprising when I say that Python can perform calculations and performs them extremely well. In fact, we saw a little example in the variables video when we created a variable called times_3 and stored the value 10 times 3. We can perform calculations in Python as if we were using a scientific calculator. For example, we can use the plus symbol for addition, so 2 plus 2 gives us 4. We can use the hyphen for subtraction, so 5 minus 3 gives us 2. We can use the asterisk or star syntax for multiplication, so 12 multiplied by 6 gives us 72, and we can also use the / for division, so 20 divided by 4 gives us 5. Now notice that when we use the division operator, the result is translated into a floating point number, i.e. a float. This is because Python converts all integers, i.e. whole numbers, to floats before performing a division calculation. Now when dividing in Python, you may also sometimes run into what is known as the zero division error. Now this occurs when you try to divide a number by 0. So as an example, if I type 10 divided by 0, you can see the error accordingly. So keep this in mind if you ever come across this issue. Now remembering what our maths teachers taught us at school, mathematical operations have an order in which they are performed, and Python is no different. Fortunately for us, Python follows the same standard mathematical order of operations. So if I were to type out 5 plus 2 multiplied by 5, we get 15 as the result, as Python first calculates the multiplication followed by the addition. To change the calculation to address the addition first, we can use brackets like so. And we then get 35 as the result when we run the code. Now when we assign values to variables, we've seen we can use these variables in other places in our code. Now we can use these variables in calculations as if they were the original literal value. So if we had a variable called sales which stored a value of 1000, a variable called cost which stored the value of 465, and then had a variable called profit which stored sales minus cost i.e. we're using the variable names. If we print out the values stored in the profit variable, we get 535 returned. Now, performing a calculation does not change the original value of the variable. So if I were to print out the value stored in sales, you can see that we still have the value of 1000 stored inside of it. Now, if I were to update the value stored in the sales variable to say 1300 and rerun the code, you can see we now get a different profit figure as the value stored in sales was updated, and as the profit calculation references the sales number, we get an updated result. And if I run the print sales line of code, we get the updated value of 1300. So things to remember from this video. Numbers can be whole numbers, which are known as integers, or numbers can contain decimal figures, which are known as floating point numbers. You can assign them to variables, and you can then include the variables in calculations. Calculations follow the standard mathematical order of operations, and you can use addition, subtraction, multiplication, and division as you would on a standard calculator.